This is our third and final part of California geology. We're working now on the metamorphic rocks in the state. For your geologic map that you're coloring, we're going to add in the Mesozoic Franciscan Knoxville group in green. And then we're going to use this brown for a unit that really is putting together all kinds of things. It's really simplifying a lot of different kinds of rocks. I'll show you that at the end. It's Precambrian to recent, which is the entire geologic timescale, primarily the rocks out here of the Mojave Desert and the beginning of the Basin and Range province. So we'll get to that. This is what those regions look like. Again, I have colored just the green and the brown, just the metamorphic rocks, or basically the metamorphic rocks and the Basin and Range province, to help you see where those parts are located. But this should all go on the map that already has your igneous and sedimentary rocks colored on it. So we're going to go back to the same picture we've looked at before of Mesozoic subduction. And we're going to zoom in on what's going on at the subduction zone interface, where the trenches, where those two plates are colliding. And one thing that's occurring is the formation of an accretionary wedge. And this is where sediment from the downgoing plate is being scraped off and accumulating at this region right here. And I've written this here so you can write it down. Sediment is scraped off of the subducting plate and stuck basically onto the overriding plate, or accreted is the word. That's where accretionary wedge comes from, because it's kind of wedge shaped. And this region actually winds up experiencing some high pressure, low temperature metamorphism. And so that's where these rocks become metamorphosed. This is subduction zone metamorphism. It's actually in the blue schist facies of metamorphic conditions. We haven't talked too much about metamorphism in this class because we just didn't have time. But this is in California what's known as the Franciscan assemblage. And so if we go back to the map here to the green unit, it says Mesozoic Franciscan Knoxville group. So that is what is shown here in green. It's mostly in the northern part of the state. There's a little bit down here in the central part of the state. And as seen with these sedimentary rocks that are here, and even some of the igneous units, it has been sliced and diced by the San Andreas Fault system. I want to look at another part of what's going on offshore here. We're going to go further to the west, and we're going to go all the way to where the Farallon plate is actually forming at a divergent plate boundary. So way off to the west, we have the Pacific and Farallon plates separating at a divergent plate boundary. And at this divergent plate boundary, as is the case with most divergent plate boundaries, we often have hydrothermal activity from water being heated from the magma chamber that's located down here. And this leaches away metals and forms those chimneys at black smokers and white smokers, and it precipitates metals such as gold. And so in this case, we did have indeed some gold being precipitated at this plate boundary, and I just put a little gold symbol. And of course, what that does is that puts gold in the entire oceanic plate. And so I've just put gold in here because this is going to be where the source of gold actually comes from that we have in California today. Sometimes oceanic plates have terrains embedded in them, such as island arcs of volcanoes or hotspot arcs of volcanoes. And as these terrains move with the rest of the plate, they eventually hit the subduction zone and they get stuck. They can't go down the subduction zone, and these are called accreted terrains. They're plastered against this upper plate as the downgoing plate goes down. They get stuck. A really large-scale example would be India getting stuck against Asia as that plate that India was riding on was subducting below Asia. We have lots of accreted terrains along the west coast of North America from the long 200 million year history of subduction in this area. Now, I've just shown one of them, but I've also made a point of the gold. So the gold wound up being plastered on the side of the Sierra Nevada mountain range. So this is the source of the gold. It was actually brought from mid-ocean ridges all the way to be accreted onto the side of North America in California along the western Sierra Nevada mountains, and also up in the Klamath Mountains as well. Now, I hate to give you a picture that's not drawn because you can't really draw this, but this is going to show you a bit better how those two things I just described overlap. So here is the ocean ridge, here's the subducting plate, here's North America. Here are the accreted terrains, and I just showed you one, but there were many accreted terrains, and here's an example of some other ones that are going to arrive at the trench and get scraped off and be stuck. And then also we have the accretionary wedge sediments being mixed in with them. So this whole region is very complicated, but it's low temperature, high pressure metamorphic conditions. Those are the metamorphic rocks represented in California on the map that we've been looking at. Right here in this region, high pressure, low temperature metamorphic conditions. I want to look at this green unit again, and it's very simplified on the map you're coloring. This other map that I've referred to once in a while shows the green. We've used the same color green, but within the green you'll notice these purple splotches, and I know it's cut off here, but it says serpentinized ultramafic rocks. These are ophiolites. And you'll notice not only are they within the green units, but they're also up here in the Klamath Mountains and in the Western Sierra. And so in here, the Klamath Mountains and the Western Sierra, we colored all one color red. Over here in the map, they've been divided into blue and red because they've kind of separated out some of the ages. Doesn't really matter. But the point is, all of these purple rocks are ophiolites. So what are ophiolites? I talked about ophiolites in Learning Video Rocks 6B.5 Part 2. So if you don't remember or you didn't catch that one, please go back and look at it. And ophiolites are a sequence of rocks that can sometimes be pushed up onto the continent, and they're basically a chunk of the ocean crust. So we start with deep sea sediments that have fallen onto the ocean crust. We have basalts represented by pillow basalts, which extrude into the ocean water, so they're kind of a funny shape, they're pillow shaped. We have sheeted dike complexes, gabbro, these are all mafic, and then we have ultramafic peridotite and other rocks. The gabbro to peridotite change right there represents the moho, the crust mantle boundary. And as I mentioned in that other video, in California we have lots of ophiolites. Here are places where we have pieces of the Coast Range ophiolite. We have other ophiolite suites as well. Few pictures of some in California. The deep sea sediments are represented quite nicely by the Marin Headlands tilted chert beds. Cherts are sedimentary rocks that form at the seafloor, and they've been tilted and brought to the surface here. Pillow basalts are shown here. Again, very unusual type of basalt because they're erupted directly into cold seawater. We have some sheeted dikes here. Not very good picture, you can't see very well, but these are basically dikes that intrude more dikes that intrude more dikes, so you can't even tell what the original rock was that was intruded because there's so much magma intruding again and again and again. Here's a tilted example of layered gabbro. This is the intrusive mafic rock, and we can see some layering here. And when I looked for California peridotites, I mostly just found hand samples. So here's a peridotite, and here's olivine, which is one of the main minerals in peridotite. California's state rock is serpentinite. So where does that fit into all of this? Well, serpentinite is a metamorphic rock that's formed from the alteration of ultramafic rocks. So here's an example of a couple outcrops of serpentinite, and here's an outcrop of serpentinite near the Golden Gate Bridge in San Francisco. It's very weak. It breaks apart very easily, and that's why this outcrop looks all crumbly. So basically that ultramafic rock is being exposed to metamorphic conditions, often involving fluid, and it turns it into serpentinite. So here we are back to our present day, and now I'm going to make a little adjustment. I'm going to just color the Sierra Nevadas all red instead of having all these different colored plutons, since that corresponds to our map. And I'm going to add the green of the metamorphic rocks sort of underneath, involved with the sedimentary units. Some of it pushed over here as an exotic terrain with gold. And now we're going to finish up with our brown unit. So as I said, our brown unit is represented over here and really is simplified. If we look at the map that is more detailed, you can see that this all brown region that we're coloring here is really lots and lots of different colors of the basin and range. Now the basin and range I talked about in the Yosemite video, And this is showing the extent of the basin and range. You can see that little triangle wedge is that triangle wedge here in California. And this is a region that began extending between 25 and 30 million years ago. And we don't have time to talk about the entire nature of that extension. But what happened was this region extended in an east-west direction, and we wound up with long north-south trending basins with young sediment and long north-south trending ranges or mountains, and those mountains had rocks of various ages. So what you're seeing over here, and it's a little bit more disorganized, it's not quite north-south in the Mojave Desert, but up here, the yellow represents these sediments, these young things, and then the colors represent all different kinds of ages of mountain ranges. We're just on the western edge of the Basin and Range Province in California, and it extends further to the east into Nevada, Arizona, Utah, etc. And so for my cross-section, I'm just going to color all of this brown, assuming all of these Precambrian rocks are underneath us, and then we're going to color brown the Basin and Range, which is what's represented to the east of this major normal fault. So here is the completed map. This is what you should have by now. I hope you have understood the various parts of California geology. It was a quick and sort of simple overview, but hopefully you have a much better understanding of California geology now that you've taken this class.